Hi everyone, in this video I'm going to introduce this real programming language. So these are very common in all the computer programming language, like if, while, and for loop, and these two are additional commands I'm going to introduce, for example, but you will use this a lot: square root function and floor function. Another thing I'd like to mention here is when you go through all the programming, you will probably encounter a lot of errors when you try to run it. And I myself was annoyed a lot by those lots of errors, a little mistake I create along the way to implement this own ideas into the computer programming language. But that made me think that the following, and that made me realize that how sloppy I am sometimes when you think through some of the technical stuff. When you put it into programming language, the computer is telling you you are not absolutely correct. So I personally take this a moment of discipline myself and go through this very intimate moment of dealing with your thought process. That it'll tell you every mistake you make, every little mistake you make out of each step until to the final goal. When you write down mathematical proofs on a piece of paper, you go through this self-examination yourself, like I encouraged you to do last time. But it's very difficult to be perfect and absolutely correct. You only focus on the part you want to focus on. Didn't have really opportunity to thoroughly go through all the validity of everything you claim and every details and technical details. But when you run it, it'll tell you, when there's an error. Sometimes the first time you run through everything okay, and then as you go through more example and you realize that the program is not working properly and realize that there's actually glitches that you didn't see before, things like that. It all boils down to the moments of a lot of annoyed moments you can encounter, but myself took that as a important lesson to analyze your thought process and everything. So don't annoy by this thing. This is telling you that every step of the way you have to be absolutely careful with what you're thinking and what you're writing it down. And that's exactly the quality that you need to carry around when you're doing mathematics. But first, the command we're going to study is this while command. So here's a while command, and let me explain each line. Actually, I forgot, maybe introduce the problem first. So here's the problem. We're about to learn the while command, and here's the sequence that is recursively defined. First term is labeled with the index 0, A0, and the second term is both a 1. So if you have two terms, and this is how you create the third term that follows after this two term. So now you have A0 and A1, and because of that you have A2. Then with A1 and A2 you create A3 and so on. So in here in the Sage we just implement exactly this idea. We're not doing mathematics to figure out the formula or anything. Just create this, implement this idea exactly to this computer program. So in the first line, this A and B are representing two terms. A is the one term and B is the next term, and C is supposed to be the third term. So 1 and 1, these are the first two terms, and we are storing this 1 and 1 as the first two terms of this list. And in this part in here, we're going to create third term. Using the second and third term, we're going to create the fourth term, and so on. So we're not going to do this indefinitely. We're going to stop at some point, but this while is telling you when to stop. This A, B, and C is the first of three successive terms, and A is the first in that three terms. Whenever that term is exceeding 150, we're going to stop. We're only doing this, keep creating the next term out of these two given terms. Only that first term of that 3 is less than 150. Whenever it exceeds, it stops doing that and get out of this while loop. It's a very, very convenient command because it's just dealing with the condition. Doesn't have to be you don't have to specify exactly when and what value that it is and what term it has to stop this loop. It's very, very convenient. So notice that this indentation is absolutely necessary in Sage. Then this indentation tells you that this 3 lines, because they're indented, that it's under this while loop. A is less than 1, and A is 1 is less than 150, so we're going to do this 3 line. C is the third term, and you can see this came from that recursive relation. Which is a recursive relation here? That's the A, and that's the B term, and that's how you create C, right? This is the AN minus 1, that's A, and second term B, and third term C. That's how they're related. So here it is. So you got this third term, and you're going to append that element to this list, and this is how you do it. So once you have A and B and C, the role of first 2 terms switches. The B is going to be A, and the C is going to be the second term. And then you repeat this over and over again. And it's going to exit this repetition whenever our first term A is less than 150. So this non-indentation indicates that that's the end of it. So once you escape that while loop, and you know A is going to eventually increase to that number, 150, then if you just type list, and it's going to show the result, what it's stored there. So this is number 1 and 1, and if you go through that algorithm, 3, if you use 1 and 3 with that algorithm, it's going to give you 5, and so on. So you can verify each of them by hand to see if this is doing correctly, and then you can increase a lot further and have a confidence that this is doing all right, or something like that. All right, this is called while loop, and it uses this condition. Let me add this part. And using induction, we were able to prove that the recursive definition of the sequence has this closed formula, and you can prove that using induction. Discovering this formula will take a lot more work, obviously. So here's the recursive idea implemented into the Sage as it is exactly, just producing using exactly the defining rule, and the mathematics shows that this is supposed to be the same as that. So let me explain this part. These are all introduced earlier. One thing you have to be careful is before you use this x as a variable, you must declare this as a variable in this fashion. You declare that as a variable. So here n is a variable, and then we're going to define this formula as capital AX. And that's what we have here. AX is defined as this closed formula, and you go through whatever I counted it in advance. So you go through and plugging in k beginning with a 0 all the way up to 9, right? So there's 10 items there, but index starts from 0 to 9 in here. And you plug in all those values and create this list. And then you can compare it with the earlier list. That's exactly the same. So one way to verify this statement using the Sage. Of course, that's not the hard way we prove it. The next command I'd like to talk about is this if command. It's very, very useful. You'll be using this a lot. So in the while command, I already showed you about some conditional statement whose result is true or false. So if deals with this condition. So this is how it goes. If 4 is equal to 3, so this double equal sign is the conditional statement. If you just use one equal symbol, that will be an assignment. We are storing 3 to supposed to be variable, so you will get an error message. So you have to have this, sorry about that, we have to have this double equal symbol. If 4 is equal to 3, and that's the end of the condition using this colon symbol there, and indentation, and print yes, this is correct. And if not, and don't do anything because there's no other command. This is because it's not indented, it said that this part says that that's the end of if command. So what this says is if 4 is equal to 3, print yes. If 4 is not equal to 3, don't do anything. That's what it says. So this is a separate command. It's out of that if condition. Just no matter what, we're going to print done. That's how it goes. So if you run this command, you will see yes, because 4 is equal to 3, and you will see done printed out. In next line, I'm trying to show how to combine multiple conditions. So this is if 1 is less than or equal to 2 and 2 is less than 3, then we're going to print yes. Of course, it is true, it's going to print yes. But there are other variations I'd like to show. For example, you can use this word or in there. If 1 is less than or equal to 2, which is true, or 5 is less than 3, which is not true, but together its logic value is true because at least one statement is true. So it's going to print out yes in there. So we're going to see, we're going to run this. So I ran it, and this is yes and done. It's printed it here. Sorry, I definitely misspoke about that. 4 is not equal to 3. Sorry about that. 4 is not equal to 3, so we don't have yes in there. And done. And that part is absolutely true, so that we have. All right, I reran it. There was an earlier result still left out there. That's why it looked weird. So that's that. So I'm going to change to and this time. So this is and condition. Of course, this is true, but this is not true. So we expect that it's not going to do anything. So it only gave us done there. So we use this a lot. Only we do some action when this is true, but we also do some action when it is not true. So the following will show us how to deal with that. So here's how you do it. If this entire logical value is true, then we're going to do print yes. If not, no indentation and colon, remember that, and we're going to print no. So if you do that, you will have no this time. So I ran it, and you have a no in there. All right, let me also introduce this else if there's a complicated logical condition. So suppose there's one condition we applied it here. If it is yes, and we're going to do this task. If it is not, then we're going to apply another condition here and then branch out like this. You can imagine there's a trees of a complicated situation like this. So this is yes case, and then below is a no case. So when it's a no, we're going to apply another condition. So I read it wrong. It's actually command and then sage is elif, but it is shorthand for else if. So here I wrote it down, the same part. If a is less than or equal to 2 and 5 is less than 3, and print yes. And of course, it's not true. If not so, we're going to test it was 5 greater than 3. Then we ask that if that was yes, then we're going to print got it here. And if you run it, and you will see the got it part showed up, then done was from the earlier part of the command. Hope that makes sense. And you can continue branch out with this else if command, elif command.